I have to solder two of these breakout boards for HB100 microwave Doppler modules. They were designed by Limpkin FR, a card and some links in the description. Obviously, most of the parts are SMD. To make things a little bit more interesting, we'll do a shootout. So one board will be reflowed on a hot plate and the other board will be manually soldered using a soldering iron. Don't worry, most of the video will be time-lapsed, though I show you each and every step, but yeah, very compressed, and I'll give you the information about how long each step took. So for the reflowed board, of course, we have three major steps. I have to apply the soldering paste, I have to place the parts, and then I have to reflow it. For the other board, I will put a dab of solder on each other pad, and then I will place the parts, and then I will solder the rest of the pads. Very important when you do SMD soldering, you have to organize your parts. And yeah, I will put mine into these boxes. This is not a real SMD part organization system, for manual assembly, but it's what I have. I printed out some map, so I know which part is in which box, and that's the very first step, putting the parts, the right number, in the right boxes, and then we can start soldering. And this step, of course, has to be done twice, once for reflow and once for soldering with the soldering iron. There are better ways to do that, of course. You could use tape holders for these SMD parts, but they don't really work for these short segments of tape I got here. Or you could glue the tape to some cardboard, whatever. That was quite fiddly, getting the parts out of the tape, especially at the start of the tape, peeling off that start. But anyway, they're in here now. And just as a sanity check, I counted the number of parts in each and every box. So that I just to be sure I didn't mix things up here, and empty. That's okay. It looks good. Time to get cracking with the solder paste. There are better techniques available here too. First of all, I could use a smaller tip. Second, I learned that it helps to heat up the pads a little bit when putting the solder paste on it. And finally, you can spend a lot of dollars for an automatic solder paste dispenser. Now, that was tedious work, as always. Remind me to order a solder paste stencil next time for $7 or so. And we cut the time down here to about a few minutes instead of, I don't know what it was, 15? Now it's time to put the SMD parts onto the board, and I have here in large print a plan where the different parts go. So let's do it. Okay. Of course, you could use vacuum tweezers, but at least for the cheaper ones, the smallest tips there are 3 millimeters, and I'm doubtful that you are really able to place these 0805 parts with them. Also, I make here the mistake that I'm trying to reorient, when they are, especially the resistors, when they are flipped over, I try to reorient the part on the board, and that's tedious. It's better to do that in the box. Yeah, just lift it up, let it fall down again, and you got a 50-50 chance that it lands on the right side. Anything else? Yeah, in between here, I actually mixed two capacitors, and it took me a while to figure out, yeah, which one I mixed up. So, yeah. So the whole process simply took much longer than I expected. But anyway, I got it done. That took longer than I expected. Yeah, a little faux pas. I mixed up, obviously, one of the 2.2 microfarad and 100 nanofarad resistors. I marked them here. I hope I sorted that out, and I noticed that, of course, because the case where the last 2.2 nanofarad capacitor should come out was empty, and there was still one 0.1 microfarad capacitor left. Yeah, I'm a little bit rattled, but anyway, let's continue with the reflow. It's always very gratifying for me to watch such an SMD board reflow on a hot plate. Yeah, it's plugged in now, and things are heating up slowly, of course, very slowly. But yeah, we're getting there. You can see the fumes coming off here a wee bit, and yeah, what can I tell you? It's gratifying just to watch it. Yeah, as the first blobs of solder paste turn into actual pin. And yeah, very important. There is a mishap going to happen here. Yeah, a happening mishap. Yeah, have a look at the left top corner, the capacitor and the resistor there. They do a funny thing. Any second now or not? Okay, so everything's hot, and yeah, the parts start to move on the pads, and come on. Did it really take that long? Well, obviously. Sorry for blabbering. Okay, yeah, there. Now we are on temperature and everything is hunky-dory, but for the top left, watch the top left, watch for it, watch for it, watch for it, watch for it. Yeah. No, that was not nice. But anyway, the board is finished now. Yeah, inspecting that problem here. I mean, it might be electrically okay, but I will correct it. Everything else seems to be, yeah, fine. Yeah, nice. As always when reflowing stuff. No problems there. Absolutely not. But for that. And now I'm going to correct that little problem. Yeah, just a little bit of hot air until, yeah, the solder for the resistor is melting. Yeah, I'm struggling a bit here to grab it because, yeah, there's not much space. Anyway, a little bit of hot air, and any second now the part comes loose. Nice. So I reorient it a little bit and reflow it again. Yeah, there's not much solder left on the right pad, so I apply a little bit more solder paste any second now. Well, I have to grab it, I'm sorry. But eventually, yeah, here I am applying a little bit more solder paste. Just a wee bit, and then some more hot air. Yes. And yeah, basically we're done. There's not much else here, and that was the only correction I had to make. So let's solder the second board with the soldering iron. And of course I still have here my plan, so I know which part goes where, and I already pre-sorted the SMD parts in my little box here. The challenge here is to put a dab of solder really only on each other pad. Yeah. Now that was phase 1, putting a dab of solder on every other pin. Now let's place the parts. Placing the parts here is actually a little bit easier. Of course, I have learned to turn around the part if the resistors are upside down in the box. But yeah, it's not as fiddly as placing the stuff on 2 blobs of solder paste. An exception here might be placing the chips as we... And now for soldering the opposite pins, for the 2-pin parts and the rest of the pins for the integrated circuits. Yeah, for the resistors and the capacitors, it's easy enough. We'll see there's only one place there where I have to do a little bit of rework after optical inspection. Though placing the multi-pin parts, yeah, there will be a lot of rework, as we see here. Yeah. Okay, that was the soldering iron approach. Let me solder in both boards some pin headers, and then we test them if they work. Quick function test, and there will be more details about that HB100 breakout board from Limkin in an upcoming video. But for now, it's suffice to say you feed in a very low amplitude, so millivolts to 10, 20 millivolts sine wave. Yeah, that's that very noisy thing here. And you should get out, well, a square wave with the same frequency. And yeah, I'm powering that, by the way, with my brand new Ovon P4305 power supply. Yeah, unboxing card link. Anyway, that board seems to be dead like a dodo. So let's try the other board. And I have obviously problems here with my ground point. And it's okay, that's a really noisy signal that I'm feeding in here, because that breakout board needs to be able to work with such a very noisy signal, because you won't get anything better look at that. So from that signal it generates a nice 2.5 volt square wave, and we're currently at a signal level, according to that FY6800 signal generator, of 10 millivolts. So let's turn that down. And the oscilloscope doesn't lie, it's that noisy. And I've got the 20 megahertz limiter in, so that's 5 millivolts. It's still detecting that there is somewhere in here a sine wave with a 10 hertz frequency, 4 millivolts, 3 millivolts. 2 millivolts, 1 millivolt. It's basically noise. It's still detecting it. There is a lot of filtering in here. But yeah, bottom line, that board works. And I somewhere at some point made a mistake with that board. So yeah, and that's the hand soldered board. So I'm going into debugging mode now here. I'm buzzing out the board here, and yeah, nothing else I can do right now. So, but I found the error. No problem. And I had a plan on the side while buzzing out the board, so now let's repair that sucker. Yeah, just having a look here, yeah, it's the left pin in the foreground on the chip. And yeah, it's dangling. And you can also see a second pin on the right pin row there. The pad is not vetted at all. And unfortunately, I lost the footage while I did the repair. Okay. And look at that. It's working now. Yeah, down to, I'm feeding currently, yeah, according to the FY68000, a 1 millivolt sine wave somewhere in here, and I get a 10 hertz and I get a 10 hertz square wave out. So I'm happy. Now let me clean these two boards real quick, and then we'll wrap things up. To answer the most relevant questions, well, the only relevant question first. Which of the boards looks better? Of course, the reflowed one. I mean, look at that beauty. And look at the ugliness here, especially at the pins of the chips and yeah, here and yeah. Reflow looks better, full stop. The least of our concerns was, well, do they work? And yes, I've shown you both work indeed. Other things you might want to consider: time and effort. So for both techniques, we had to organize our parts, and it took me, yeah, almost a quarter hour to do that. Yeah, the second time when I reorganized the parts for the soldering stuff, it was 10 minutes. So really starting these SMD tapes is fiddly. Anyway, reflow, we applied the solder paste. That took me 16 minutes. And yeah, tinning one pad of each part with soldering 5.5 minutes. Placing the parts took me a whole half hour, 31 minutes for the reflow. But yeah, I had a part swap there, and yeah, I timed it in real time on the video. I needed 9.5 minutes to correct that. It was capacitors without any markings. So yeah, that was quite troublesome. Soldering then one pin, that is placing the parts and soldering one pin to the board, took me 21 minutes. Reflow itself, we saw that in real time, 2 minutes. Soldering the other pins, yeah, 15 minutes. So yeah, it's basically the same 3 steps, but they take different times. I did one hot air repair, you know, the 2 capacitors, or it was a resistor and a capacitor that cuddled up, and I had some, yeah, dead solder joints here. Buzzing out the board took me 7.5 minutes, and the repair itself 3.5 minutes. So total for reflow 50.5 minutes, total for soldering 22.5 minutes. Without the repairs, the reflow comes to 49 minutes and the soldering to just 41.5 minutes. But if we also subtract the part swap that happened here, then yeah, the reflow is at 39.5 minutes and compared to 41.5 minutes. So yeah, we're even again. However, if we would have used a stencil to apply the solder paste, yeah, we would have cut that down by a considerable amount the time here spent. So we would be down by about half an hour. And now that's the point we're really getting faster than soldering such a board. I'm a bit torn here. Yeah, I love good results, so I would probably go with a reflow each and every time. But then, if you don't have the reflow equipment, so at least some solder paste and a hot plate, you can always solder such boards with, it's possible. It's not a big deal. You can do that, even 08, 05 parts. So, what's your opinion? Let me know in the comments. And yeah, if you are a Reflow Pro, please, I want to hear from you. Of course, not all the little things I already mentioned, but if you have other pro tips for me, I want to hear them. Till next time, bye.